Please pause the video and take a moment to read this important safety message. Hey, welcome everyone. These are my favorite kind of videos to make for you guys, and they're one of my most requested that I get via email. And that is, hey, the next time you go to troubleshoot a piece of gear, Mark, could you show us the steps you go through to troubleshoot it? So, that's what we're going to do today. This is an amplifier I picked up off of Audio Karma some time back, about maybe 10 years ago or so. Didn't know anything about it other than it was a 300B amplifier, and the gentleman that was selling it, the price was right, so I picked it up. Okay. Recently, I've, for the first time ever, taken the bottom cover off of it. I've listened to this amp a lot, but really never dug into it. Come to find out, as I dissected a little bit, it's just a classic audio note design here. It's a 300B output amplifier here, and you can see the two 300Bs here. You have a single 6S7 here driving a pair of 5687 output tubes right here, and then that's driving the two 300Bs. We've got our traditional power supply over here with a 5U4, a couple sets of rectifier capacitors over here, and then we've got two transformers here for driving the filaments, but that's just a little bit, and then two humbucker pots here in the middle to reduce hum on the filaments of the 300Bs. And we've got a set of Alps pots over here for volume control. Outside of that, pretty standard classic 300B design. So let me tell you what's wrong with it. One channel, the volume is much louder than the other channel, okay? And so what this video today is going to be about is how to troubleshoot a channel imbalance in a tube amplifier of some sort, okay? There's a few things I've already done that I'm not going to show in this video, and that was, one, I tested all the tubes, okay? That didn't really solve anything. Two, I swapped the tubes around. I put the left tube in the right channel, same over here, and I even swapped out to a different 6S7. Didn't solve any of the issue, okay? The other things I've done is on the front here you got the volume pots. I've played with the making sure they were both turned up, and none of that has solved my issue of one channel being much louder than the other channel. So let's dive in and see how we would go about troubleshooting this. Okay, as you can see here on the oscilloscope display, we have one channel much higher than the other. I can grab the volume knobs on this unit and adjust them, and if you'll notice, they both go up and down, but one goes up way more than the other. And there's nothing I can physically do at this point to change this outcome right now, okay? And I'm just showing you left and right channel here, both on the oscilloscope at the same time. So the first thing that we're going to do to try to troubleshoot this is I want to check the voltages in this. And look, I don't even have a schematic, okay? So what I'm going to do is I'm going to attempt to prop up this fluke meter here. And I'm going to take one probe lead off of it, and I'm going to connect it over here to a point that is at ground right now. So one lead is on ground. The other lead here I've got in my hand. And what I'm going to do is just come over here and start checking voltages along the power supply path. So I've got 410 volts right off of the rectifier. After if you'll notice, I'm feeding out of the rectifier then into this choke here. Coming out the other side of the choke here, I've got, what, 384 volts. It then feeds from over there to this point right here, okay? And at this point should have the same 384 volts. Then we've got two little resistors here. So what they're starting to do is split rail the power supply at this point. And they're using half of this 50 microfarad capacitor right here for one channel, and they're using the other one for the other channel. So, we got a difference of about a volt there between these two, and that has nothing more than to do with the value of these carbon comp resistors that are in place right here. And so I may want to swap both these out for something a little closer matched to get the power supply rail a little closer. But then I'm going to follow down the power supply rail over here, and I'm going to see where it takes me. Okay, this is one leg of it, and I've still got my 167 volts here. And the other leg of that ends up coming, and it's hard to get to here, right down here I've still got my 166 volts. Then I've got another dropping resistor, looks like a 27K right here, that takes me down, and I'm going to just jump on the other side of it. I've got 89 volts on the other side of this dropping resistor that's feeding the 6SN7. The same here, I've got another 27K. And what have I got here on the other side of it? Whoops, wrong place. I'm doing this thing live. 87 volts on one side here, and what I have, 89 on the other. So 2 volt different on the plate of these tubes. Yes, that can make a minute difference in the output of one signal versus the other, but it's not going to make this 2x difference that we've seen here, okay? And then if I kind of follow this down here to pin number 9 on the 5687, I got that 167 volts. And I'm just going to check over here on this other one. I've got the 166 volts, as you can see. So basically, I'm getting the right voltages to these tubes at this point in time. And so next up, I'm going to go over here and I'm going to start measuring, well, what am I feeding into these, into the 300Bs. So coming off right here, feeding over, which is coming off of this this first the second section of this rectifier tube here, 383 volts. If I come over here then, I've got the same 383 volts, okay? From this point, if you'll notice, it splits into these 2 red wires right here. This is feeding down into the primaries of the output transformers. And then it'll come out the other side of the primaries of the output transformers with these blue wires right here. And what are we going to get here? 376 volts over here, and let me get this on here good. 376 volts over here. So we're staying consistent on both sides. This is one of the beauties of troubleshooting a stereo amplifier here. Oops, tube came a little loose as I must have pushed it out. But you can compare one side to the other. I do this all the time, okay? Even without a schematic, it can tell you if something is wrong going on. So I've kind of checked all this. Then I want to do is I want to start to check along the way and see if I've got maybe a problem somewhere with a leaky coupling cap, okay? So I noticed this capacitor here, which is feeding from the 5687 over to the output tube here. If you'll notice, we're coming out of this tube here, through this coupling cap, out of it, through this grid resistor, onto the grid of this tube. And if you'll notice here, I've got 0.02 volts, hardly anything. And if I come over here and do the same thing on this tube, there you go, 0.0 something volts, hardly nothing sitting on the grids right there, okay? Which is what we're looking for. And we're noticing that both sides are very, very similar there. So basically, in essence, what I've done is I can check the voltage on one side of this coupling cap, 85 volts. I'll check the value on the other side over here, okay? We've got what? Hardly 0 volts. That is a good sign. Let me move this over out of the way here so I can show you the other side. Same thing here. I'm going to check on the output side of this where it's coming from. And that's a little tough to follow down here, but it's coming off of this tube right here, 83 volts, as you can see. And then I'm going to check the other side of this cap, and I've got hardly nothing. So this cap is not leaky, this cap is not leaky. Okay, let's come over here and check this side of this cap. 89 volts on one side. I'm going to check the other side over here. The potentiometer, hardly nothing. That's good. So what that means is DC is getting blocked, AC is flowing through. If I had measured here with 89 volts, and then let's say I measured this side, and let's say I measured 3 volts, 5 volts, 10 volts, 100 volts. That would be a bad thing. That means this coupling cap is leaking DC onto the next side of it, letting it flow through. By the way, if you guys want to know how to check your coupling caps in your amp, this is how you do it. Check on one side, you'll find a voltage, 87 volts. Let's check the other side here. Hardly nothing, 0.05 volts here, okay? So that coupling cap is doing its job. Wow. Let's keep checking here. I do want to come over here to the output tubes. And let's check some voltages here, okay? I'm just checking the voltage here. That's at ground, and it should be because there's a little green wire coming over here to ground. And this is the cathode cap. So I've got 62 volts on one side of my cathode resistor and 0 volts on the other. What have I got over here? I've got 60 volts on one side of this cathode. I've got 0 volts on the other side. So I'm not finding anything DC voltage wise out of whack about this amplifier. I've pretty much gone through it now at this point. So let's switch over now and do a little bit of troubleshooting with an oscilloscope probe. Okay, what I've got going on here is nothing more than a standard oscilloscope probe. I've got it on 10x. I've got it plugged into my channel 1 here on my oscilloscope, and I'm just going to start looking for signal. So I've got signal here on the input of one jack. I've got signal here on the input of another jack. What that tells me, all I'm looking for is the magnitude of this signal on both sides is equal, okay? And I'm going to follow it on up then, and I'm going to come to where it goes into the grid of the first tube here. So I'm going to follow it up here, and it's probably hard for you guys to see, but this is the grid resistor on the first side of one side of this 6SN7, and then this is the grid resistor right here on the other side of this 6SN7. So that's the inputs of the 6SN7. In other words, I've made it all the way up through the cables. I've made it through the grid resistors on both sides of this. Now, I'm probably going to adjust my oscilloscope here a little bit because we are about to make our first stage of amplification. And we're going to check where we come out of. There we go. This is where we're coming out of the 6SN7 on one side of the triode. Okay, and then I'm going to go check where I'm coming out the other side of it on the triode. Okay, now what am I going to do? I'm going to jump the other side of the coupling cap. Notice the AC signal still flowing through, whereas we stopped the DC signal. And they're both relatively the same here. Okay, so we're feeding out of that. Then what I'm going to do is check the output I'm getting out of each one of these volume pots, right? So there we go, because I'm feeding out of the volume pot here. And I'm feeding out of the volume pot there. I'm going to check the other side of the grid resistor where we're feeding into the 5687. And I'm good there, and I'm going to check the other side of this resistor here where I'm feeding into the 5687, and I'm good there. So we've made it through the 6SN7 and the signals are staying the same. Right now we're into the 5687, the first one, okay? And now I'm going to check the output of that. And I'm going to have to get my, it's a little bit tricky here. All right, whoa, if you notice we got more amplification. I got to crank this down. So there's on one side 9.34 volts going into the 6, right there, and then let me check right here. What do we got? 9.18. So we're on the outputs of these 5687, this totem pole stack, we're good, okay? So, and then let's check the other side of these coupling caps, 9 point some volts. Let me check the other side of this coupling cap, 9 point some volts. Wow. Let's check the other side of this grid resistor here going into the 300B. 9.32, 9.16. So this 9.32 versus 9.16, that's playing out all the way from way back here at the beginning when we had a little bit of voltage offset, and it's getting amplified along the way. But as you can see, it's negligible. Your ears would never hear it, even though we can measure it over here. So okay, I'm driving both of these output tubes with the exact same voltage. What the heck's going on here? Let's check this. I'm going to check the top side of the cathode here, okay, on one tube, right? No voltage there. I'm going to check the top side of the cathode over here. What the heck? So let's do that one more time. Cathode, top side, no signal. Why? Because the signal is going out through the tube, out through the plate of the tube. Well, we've got something going on here. Our cathode capacitor right here is not doing its job, and if I was betting right now, I'm betting it's leaky. Look, I'm betting it's leaky, and it's providing it's basically reducing the gain of this amplifier significantly at this point. So you notice I had no schematic. I'm far from having the schematic for this unit memorized. I'm just kind of walking through it. Now you may need a schematic if you're not familiar with which pins are the grid and which pins are the plate and things of that nature. But this is interesting here. So we're going to try something. Okay, here we go. So what I'm going to do now, and I'll put the screen display back up so you can see both sides of the output channel. I have a similar size capacitor here, and what I've done is connected 2 banana jacks to it. Okay, and I would not recommend you do this at home. If you do this at home, please power this amplifier down and use some kind of device to drain the capacitors, then hook this up and then disconnect it. I know that I'm dealing with 65 volts sitting right here, which is not going to kill me. So what I'm going to do here is I'm going to parallel this capacitor, this cathode bypass capacitor right here, with this capacitor that I'm going to sit here off screen so you can't see it. But I'm going to connect this, and I'll be darned. Let's take a look at what we've got now. Pretty much 2 exactly superimposed signals over each other. Keep in mind, slight difference here because of that voltage drop that kind of got skewed all along the way here. That's why if you're going to split rail, make sure your voltages as you start getting into things are pretty identical. But we just solved our problem. This cap was not doing its job, and at the end of the day is what was failing us, reducing the gain in the output stage, because if you don't have a cathode bypass capacitor, this is basically in essence what you end up with. Alright, I thought I'd show you this real quick. Notice the end of this capacitor here, how it is slightly bulging there on the end. And then if you pay close attention to it and get up close, you can actually see that it's been leaking. Definitely a bad cap. One other thing I thought I might show you, this ground connection here, I feed up and into my oscilloscope. I find that easier than putting a little ground probe on this as you're trying to move this around all inside the amplifier. If you're going to do that, I use an isolation transformer on the other side of this to keep from having any kind of house versus audio path or chassis grounding issues here. Alright, just for you guys and for fun and giggles, I ended up drawing up this amplifier, reverse engineered it here. And if you'll notice here, I'm just going to show you what all we measured. Remember, we measured coming right at the top of this cap, coming right after the rectifier, and we found our voltage here. Then we measured on the other side of this inductor. We found our voltage here. If you remember, then we went to this point where it was doing the split rail and it had the 227Ks. We measured here. We measured on the other side of these 227Ks. That's when we started to see a little bit of voltage different, a few volts there, or a volt or two. Then we measured again on the other side of these 27K resistors, and that's where we saw a little bit more voltage difference. Keep in mind, that was not our problem. That just attributed to the slight indifference in the outputs, not the massive indifference in the outputs, okay? Okay, let's finish up where we made our DC measurements here. If you'll remember, from a DC standpoint, we measured right here on the plate of this. We measured on the other side of it here, right? We made sure this coupling cap wasn't leaking. We measured here on the other side of this grid resistor going into this totem pole stack. We measured up here the B plus on it. We measured the voltage coming out of the cathode of this. We made sure this coupling cap wasn't leaking. We measured on the other side here of this, this grid resistor going into this. We also measured the B plus at the top of the output transformer and here at the plate, right? We measured our DC resistance here and here, right? Didn't see anything out of whack at that point. Okay, up next, we grabbed our oscilloscope probe. We measured the RCA input. Keep in mind, this whole schematic right here is one channel, like the left channel, right? We compared the left channel to the right channel. Didn't see any difference. We went on the other side of this grid resistor, left channel, right channel. Didn't see any difference. We went to the plate of this tube and the one on the other channel. Didn't see any difference. We went on the other side of this coupling cap. Didn't see any difference. Went to the other side of this grid resistor, didn't see any difference. We came here to the output of the cathode of this 5687 here, didn't see any difference left and right. We went the other side of this coupling cap, didn't see any difference. We came back and we went all the way to the other side of the grid resistor to the input of the 300B, didn't see a difference between left and right. It wasn't until we got our meter right here on the cathode that we saw a difference between the left and right channel. And what's really going on here is with this cathode capacitor here bypassing this resistor, what it does is it gets rid of something called negative degeneration, cathode negative degeneration. In other words, basically it's a form of negative feedback that it's canceling out that causes a massive reduction in gain. And that's what we were seeing. We basically didn't have this capacitor in play at all on our circuit. And then what I did, remember, capacitors when put in parallel with each other, they add to each other. So I just came in here and put a capacitor in place in parallel with that, giving it the capacitance it needed to eliminate this negative degeneration. And as soon as we did, it lifted the gain up on this tube and our output looked fine. So just wanted to walk you through from a schematic standpoint. Hope you guys enjoyed this video. I sure as heck did, had a lot of fun. We'll keep making these. See you guys again soon.